Welcome to day 3, quadratic functions. We will be looking at how we can graph and write equations of quadratic functions and solve quadratics by factoring. There are 3 different forms for quadratics, and we'll go through them right now. You should know a quadratic function will always give this U-shape called a parabola, and the 3 different forms are the vertex form, the factored form or x-intercept form, and the standard form. We're going to look at all 3 of them today and how they have different ways to graph. If you notice very carefully, all 3 forms have an A up front. So there's an A here, there's an A here, there's an A here, and they all have an x raised to the second power. 2 x's are here, an x squared. So all 3 forms have ax squared. That's very important because the a in the ax squared, as you can see, gives its direction and shape of the parabola. And what do I mean by that? Well, let's screw in a little bit. When a is a positive number, it is going to look like this, concave up. When a is a negative number, it's going to look like this, concave down. When absolute value of a is bigger than 1, it is going to be vertically stretched. Usually it's going to get skinnier. It's going to be very narrow. And, when the absolute value of a is less than 1, like a fraction or a decimal, it's going to be a vertical compression. That means it's going to get very wide. So the idea I talk about the values of a being bigger than 1 or smaller than 1, if you have a number for a like 5, it's going to stretch that parabola vertically by 5. And if you took a marshmallow and stretched it 5 times vertically, it's going to get skinny or narrow. And if you had a value of something like a half, and you took a marshmallow and squished it in half vertically, you're just going to squash it down a little bit, it's going to get wider. So let's talk about each form that we're going to do. First I'm going to do the vertex form. It's probably the easiest one of the easiest one to graph. And the idea is that the vertex form has a vertex built into the equation. If you look in the equation, you have x minus h inside the parentheses, and then the plus k in the outside. Well, anything inside the parentheses with the letter x is the opposite effect, so the vertex is going to be positive hk. So I put that dot over here. So this vertex, one way to write it is positive hk. That is the order pair for that vertex. The axis of symmetry is the vertical line that goes through the middle of the parabola. I'm going to do that in red. So in this case, it would be this vertical line. We call this the axis of symmetry. And the axis of symmetry is just the x value of the vertex. So for this example, my axis is going to be x equals h. Okay? That's all I really get from this. Now if I want to ever find, I have other points on here. I have a y-intercept here. I have what I call its buddy point, or this point symmetric to the y-intercept. And here is one x-intercept, and here's another x-intercept. So the great thing about a parabola, every point on the parabola has a buddy point over the axis of symmetry. So like even this point way up here has the buddy point way here, and vice versa. Okay, so if I wanted to find other things, probably the easiest thing to do is find the y-intercept. The y-intercept always is going to be use x equals 0. So this would be 0 comma f of 0. Whatever you get, the y-intercept will always be 0 comma f of 0. And the buddy point, if you notice, if this red line is h, then this other point here is double that. So the buddy point is always going to be 2h, and the y value is the same, f of 0. Okay, I think that's all we're looking at from the vertex form. So let's look at the factored form, the x-intercept form. I'm going to do that in purple. Okay, this one is written out differently. I have a times 2 sets of parentheses, and these values inside the parentheses are called the roots. That's why I use the letter r, or the x-intercepts. So let's call this r1 comma 0. And this guy over here is r2 comma 0. And if I notice, the axis of symmetry is right in the middle of these two dots. The axis of symmetry is always going to be in the middle of two dots that are on the same y. So in the middle, how do you find the middle of two things? Well, to find the middle of two things, I just add them together and divide by 2. So this axis of symmetry is going to be x equals r1 plus r2 over 2. And now if I want to find my vertex, I'm going to move this up just a little bit. If I want to find my vertex, I have to take that x value that I just had for the axis of symmetry, r1 plus r2 over 2, and plug that into the f function, f of r1 plus r2 over 2, and that would be the vertex, because the most important point on a parabola is the vertex. It's kind of where every parabola starts. It either starts at the bottom and goes up, or starts at the top and goes down. And then I have that. Okay. The other thing I have is standard form, which I don't use that often, but I can. And standard form is ax squared plus bx plus c. Now, it doesn't give me the vertex, it doesn't give me the x-intercepts, it doesn't give me any of that. I could find the y-intercept easily by plugging in 0, but the axis of symmetry have a very special formula right here. X equals negative b over 2a. And once I have the x value of the axis of symmetry, I could plug that into the function and get its vertex as negative b over 2a and f of negative b over 2a. Okay, and that's how I find some key features on this graph, but there's other things we need to do, such as x-intercepts and so on and so forth. So when you have standard form, one special way to find the x-intercepts is using the quadratic formula. Now, I'm never going to make you memorize it, but the quadratic formula will always find you the x-intercepts, or what we call the solution of the quadratic. Okay, so I've used some words synonymous here. Let me write this down at the bottom. I'm going to use blue. We talked about x-intercepts. I also called it a root. Another name for it is called a zero, because that's where y equals 0. These are all synonymous. And once in a while, we call it the solution when we're solving a quadratic equation. These are all synonymous words. They all mean each other. Now, I already talked about how every parabola, all three forms, had ax squared, where a gives us a shape. In fact, every parabola is ax squared, and then we just move the vertex left or right or up and down. But if I want to actually graph a parabola from the vertex, I have a method called counting squares from the vertex, and I'll go through it on my examples on the next pages. And the idea is this. To me, the vertex is so important to me, that's why I should try to start drawing every parabola. And the way I do that, I do the number of x squares from the vertex, and that's my x value, and a parabola is x squared, and then I'm going to multiply it by the a value, and then it's going to be the number of y squares from a vertex. And I'll go through it in an example, but to me, I don't like calculating a bunch of points. I like starting at the vertex and counting squares. I'm very good at counting squares. Okay, let's try some examples. I should read through the problem or look at a graph to decide what form I want to use. Usually it's either going to be vertex form or x-intercept form, factored form, depending what's given to me. I'm going to use vertex form here because it gives me my vertex. I'm going to use this form. I always have the equal sign as an a value. And now I could put in for the h and the k. Y equals a x plus 2 squared, don't forget your squared, minus 5. Okay, now you have to figure out the a, because a will give you its shape and direction. So that's where you have to use the other point. So I plug in negative 27 is equal to a, negative 4 plus 2 squared minus 5. Now this is where I see the biggest mistake. People do this, that's fine, and that's negative 4 plus 2 is negative 2 squared, which is going to be 4, so I get negative 2a is equal to a times 4 minus 5, and people think the 4 minus 5 go together. No, they do not. 4 is multiplying a, so when I put a number as a multiplier, I put it in front. 4a minus 5 is equal to negative 27. I'm going to add 5, I get negative 22 is equal to 4a. I'm going to divide by 4, and I get a is equal to negative 11 over 2, or negative 5.5. So my function is negative 11 over 2 x plus 2 squared minus 5. That is the equation of that parabola. Now, the next one, I'm given the roots. Another word for roots are x-intercepts. So I'm going to use this form. Y equals, always after the equal sign is an a, x plus, excuse me, where's my eraser? X minus one root times x minus the other root. So I got y equals a, x minus 2, x plus 6. Using my 2 and negative 6, remember inside the parentheses with the x is always the opposite. I'm going to use this other point here and plug it in for the x and y. Negative 24 equals a times, well, negative 2 times 6 is negative 12a. Divide by negative 12. I get a is equal to 2. So I have f of x is equal to 2, x minus 2, x plus 6. And the second part of the question asks, what is the vertex? Well, the vertex is in the middle of the two roots. So I have x equals 2 plus a negative 6 over 2. So I get x equals excuse me, negative 2. So this is the x value part of the vertex. I plug negative 2 in here. And when I plug negative 2, if I plug the axis of symmetry, if I plug the x value of the vertex into the equation for the quadratic, like I did here, what should happen is that the two parentheses should be opposites. So it's 2, negative 4, and 4, because the idea is that negative 2 is negative 4 spots away, or 4 spots away from 2, and negative 4 spots away from 6. And when you do all that, you get negative 32 as your result. So your vertex is the ordered pair negative 2, comma, negative 32. That is the vertex of that parabola. Okay, that's given information. Written, I could look at graphs, and again, I should notice, what do I have here? I have the vertex of 3, 7, so I'm going to use my vertex form. Y equals a, x minus 3 squared plus 7. And then I have the other information of 0, comma 1 as my ordered pair. I'm going to plug them in for the x and the y. 1 equals a, negative 3 squared plus 7. 1 equals 9a plus 7. Put that number in front of the a so you know the 9 and 7 do not go together. Subtract 7. Negative 6 equals 9a. Divide by 9. I get a equals negative 2/3. And you got to ask yourself, look at that graph. If a is a negative value, the graph better be concave down. And it is concave down. That's always my little self-check. If I got a positive value for a and I look at that graph, I got to say to myself, I messed up. So the equation of this parabola is negative 2/3 x minus 3 squared plus 7 when you rewrite it. Same thing for this one, except now you have x equals 2 and x equals negative 5. Those are my x-intercepts, so I'm going to use the x-intercept form, or y equals a, x plus 5 for the first root, x minus 2 for the second root. I have the point here, 0, comma, negative 5. I'm going to plug that in. Negative 5 equals a. Plug in 0, I get 5 times negative 2, or negative 10a. Divide by negative 10. I get a equals 1/2, and I have to ask myself, 1/2 is a positive number. My graph better be concave up. And this graph is concave up. Again, please double check your a value with the concavity of the parabola if you have a graph. So I get f of x equals 1/2 x plus 5 x minus 2. Okay, now we're going to graph some functions. I see I have this form, my vertex form, and I can look at this opposite and the y value, so my vertex is 1, 8. 1, 8. Right here is my vertex. Now, I should also make note of the a value. Here's my a value. A equals negative 2, so I better draw a graph that is concave down. Now my axis of symmetry is just the x value of the vertex, and that is x equals 1. So I'm going to draw my little axis of symmetry. It's going to help me with buddy points. X equals 1 is my axis of symmetry. How do we find a y-intercept? A y-intercept, I just use x equals 0, so f of 0 is equal to negative 2, negative 1 squared plus 8. Negative 1 squared is 1, so it's going to be negative 2 plus 8, which is 6. So I get 0, comma 6. 0, comma 6 is right here. And I could draw its buddy point, and its buddy point is just over the red symmetric line. So this is 1 square away from here, so it's 1 square away from here. And if you notice, the x value is just double the x value of the vertex, so it's going to be 2, comma 6. That's his buddy point. Now the last thing I have to do is find the x-intercepts. And one way I could find x-intercepts is is make y equal to 0 and then solve it. That's one way, and sometimes I have to do that. But I'd rather do my count squares method, where I'm going to use that the parabola is equal to y equals negative 2x squared, and using the a value. I'm going to use this a value of negative 2. So I'm going to use black, but I'm going to use the eraser. So I always start at the vertex. I don't care if you go left or right. It doesn't matter because you're always going to draw a buddy point. But remember, every time you move left or right, you're going to take how many squares you moved, x, and square it. This is a parabola. Every x is squared. So if I start here, if I go 1, x to the right, 1 squared. I know this x value is 2. I'm not using the actual x value. I'm using how many x squares away from the vertex. So 1 squared is 1 times a is negative 2. And look at that. Negative 2. And here's my buddy point. I'm going to go back to the vertex. I'm going to go over 2 squares. Doesn't matter left or right. I'll go right. 1, 2. 2 squared is 4. 4 times a value is negative 8, so I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put a dot right here. I'm going to put a dot right here. And then I notice that this dot is 1, 2 squares away from the axis of symmetry, so I have to draw this buddy dot 1, 2 squares away from the axis of symmetry on the other side. So I have a dot right here. And those are in this case, the x-intercepts of negative 1, 0, and 3, 0. And 5 dots is usually enough to draw a parabola, but if I want to do another dot, watch, I could do this again. I could go over 3 squares. I'll go left this time. 1, 2, 3. 3 squared is 9 times the a value of negative 2, which is negative 18, so I have to go down 18. Well, we already said this was 8, 13, 18. I have to draw a dot right here. So right here is another dot. And this is 1, 2, 3 squares away, so 1, 2, 3 squares away. And I really have a lot of dots to draw a parabola. And this is kind of a skinny parabola. And there we go. There's my graph of that parabola. Okay, next one is in x-intercept or factored form. My x-intercepts are the opposite of what I see, so I have x equals 1, x equals negative 3, so 1 comma 0 and negative 3 comma 0, 1 comma 0, negative 3 comma 0 are right here. I'm going to make note of that a value right here. That a value, a is equal to 3/4, so I better draw something that is concave up. The axis of symmetry is in the middle of those 2 points, so my axis of symmetry is going to be 1 plus a negative 3 over 2, which is negative 2 over 2. I have x equals negative 1 as my axis of symmetry. I'm going to draw that right here. And this is x equals negative 1. And I'm going to plug that in. I'm going to use this value to find the vertex by doing f of negative 1 by plugging it into the function. So I get 3/4, negative 1 minus 1, negative 1 plus 3. And if I do this right, I should get opposite values here. And I get 3/4 times negative 4, which is negative 3. So my vertex is negative 1, negative 3. And I can plot that. Negative 1, negative 3, which is right here. And now I want to do the y-intercept. I'm going to plug in 0. F of 0 is equal to 3/4 times negative 1 times 3, which is going to be negative 9/4. So I get 0 comma negative 9/4, which is a little bit bigger than negative 2. So it's kind of hard to plot that exactly. But it's right around here. And its buddy point is going to be 1 square away from the axis, so its buddy point would be right here. And that's double the x value of the axis of symmetry, so -2, -9/4. I could draw my parabola like this. But I do want to show how my a value does give its shape by doing ax squared. So if I go back to here, this is my vertex. My a value is 3/4. I go over 1, 2 squares. 2 squared is 4. 4 times 3/4 is 3, and I go up 3, and it works, and there's its buddy point. So that's why I always use ax squared. So the last one I'm going to do is graph in standard form. 2x squared minus 8x plus 3. My a value is 2. I better get a concave up graph. The y-intercept is the only thing that's easy to graph right now by just plugging in 0. While you plug in 0, you get 2 times 0 squared minus 8 times 0 plus 3. Oop. I guess I can move this over a little, plus 3. And I get this whole thing equal to 3. So 0, 3 is the y-intercept. Okay, now I got to find the symmetric point. Well, I can't find the symmetric point right now because I need the axis of symmetry. Well, the axis of symmetry is going to be -b over 2a. Well, this is a, and that is b. So I get -8 over 2 times 2. So I get 8 over 4. So my axis of symmetry is x is equal to 2. So I can graph the axis of symmetry here in red. Oops. Red. I get x equals 2. And now I could draw its buddy point. If this is 2 squares away from the red, I need another point 2 squares away from the red, so I get the point 4, 3 as its axis as its buddy point. But I could use this 2 value to find the vertex by doing f of 2, which is going to be 2 times 2 squared minus 8 times 2 plus 3. 4 times 2 is 8 minus 16 plus 3. I get -5 as a result. So my vertex is 2, -5. And I could plot that point right here. Then I got to figure out the x-intercepts. Well, I'm actually going to figure out another. I'm going to use my counting squares method again. So again, if I go here, my value is 2. I go over 1 squared to the right or left. 1 squared is 1 times a is 2. I'm going to put a dot here. And his buddy point is going to be over here. And then I can also go over 2 squares. I'll go left this time. 1, 2. 2 squared is 4 times a is 8, and I could go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And look, it validates the y-intercept. Technically, with 5 dots, I could draw my parabola. I know this is kind of messy, but I'm using a stylus on a computer. Now my x-intercepts, as you can see, are not nice numbers. They're here somewhere. Because they're not nice numbers, we're actually going to use the quadratic formula, which I will never make you memorize, and we get this as our results. So I turned off the recorder and I did all the side work for the quadratic formula, and you could see you get this funky numbers when you do all the math. And now when you do the quadratic formula, you should get 2 results, because it's going to be, in this case, 8 plus or minus the square root of 40 over 4. You have to do the adding part and the subtracting part, and there are 2 results, and you can see you kind of get what you get. Okay, solving by factoring. Well, again, we're going to work on factoring, and we want to find the zeros of all this. That means I'm going to set this equal to 0, and I factor all this. I get x plus 2, x minus 4. And when I solve each of them, I set them each equal to 0. And I get x is equal to negative 2. And x is equal to 4. Hopefully you can see that mentally. Now factoring, like I said, I'm not a big Xbox guy, so I'm going to set this equal to 0. And I have a choice for 4x squared. I either can do 2x times 2x, or I could do 4x times 1x. I'm going to try 2x and 2x. I got to multiply to negative 15. I should always think about multiplying to negative 15 first before I think about that negative 4 in the middle. I think 5 and 3, so I'm going to make one negative, one positive. I'm going to check it, and my outside guys are negative 10x. My inside guys are 6x, and that gives me my negative 4x in the middle that I wanted. And I set them equal to 0. I set them both equal to 0. And mentally, I know I have to do subtract 3, divide by 2, and add 5, divide by 2, and there are my 2 solutions for x squared. X squared should have 2 solutions. Hopefully this one, you recognize this pattern as a difference of 2 squares. X squared becomes x and x. 81 becomes 9 and 9. One's positive, one's negative. And when I solve them, I get negative 9 and 9 as my 2 solutions. And this last one that I'm going to do, I should always tell myself, if I can take a number out, if I can factor a number out of here, if I can factor something out, I'm going to do it. I'm going to take a 2 out of here. 2, x squared minus 4x minus 12, because it's a lot easier to factor with smaller numbers. 2 is going to be x and x. It is going to be plus 2 minus 6. Okay, now when we set them equal to x, there's no variable there, so I'm not ever solving that coefficient of 2 up front for x. I'm solving these guys for x. I get x equals negative 2 and positive 6. And again, x squared should only have 2 solutions.